Alright, welcome friends. Here we go with your Pre-Calculus Chapter 2 test review. I'm going to try to get this all done in one video, but it could very well be in two. You'll know by the time you start watching this. So let's go ahead and dive in. Alright, so your first problem was 3x plus 2 equals 15, and your goal was to solve this for x. So let's go ahead and solve it for x. We want to get x by itself. So the first thing we're going to do is we are going to subtract 2 from both sides. So we are going to say, all right, negative 3x, and then 15 minus 2 is going to be 13. And then x is going to be, we're going to divide both sides by negative 3. We're going to x is equal to negative 13 over 3. Since it said to find exact solutions, please leave your solution like a fraction. All right, leave it just like that. All right, on to the next problem. Alrighty. So, here we have this. Our goal is to get y by itself. So, first we want to distribute, clean some stuff up, and then we're going to move stuff around to get y by itself. So we distribute that 9. 9 times y is 9y. 9 times negative 2 is negative 18. 18 equals 8y plus 14. So then, our goal is to get y's all on one side and numbers all on the other. So I'm going to go ahead and add 18 to both sides. So we have 9y equals 8y. And then 14 plus 18 is 32, I think. Yeah, 32. Awesome. And then we're going to subtract 8y's from both sides. We're going to get that y is equal to 32. Okay, on to the next problem. So the next problem. Here we have two things that are multiplied to be 0. If we have two things that are multiplied to be 0, then we know that at least one of them has to be 0. In this case, we're not sure which one is 0, because 2x plus 5 could be 0, or x plus 8 could be 0. So what we need to do is we're going to, since we don't know which one is 0, we set both of them equal to 0. So we have 2x minus 5 equals 0, as well as x plus 8 equals 0. We have two separate problems. So we're going to solve the problem on the left for x. So we have 2 times x equals 5. Divide both sides by 2. We get x equals 5 over 2. You can go ahead and leave it like that. That's fine. And now over here, we're going to have x equals negative 8. So we have x equals 5 over 2, comma, negative 8. Those are our two solutions for this. Okay, you could plug them back in, see if you get a true statement, and that would be a way to check your answer. So on to the next problem. So for this problem, we are looking at a quadratic. Okay, and whenever we have a quadratic type equation, we want to make sure that first we want to check to see if we can get x squared equals some number. In that case, we're looking for there to be no just x term, which we have in this case. So we're going to go ahead and get x squared by itself. So we're going to have 4x squared, adding 64 to both sides is going to make this 64. And then we're going to divide both sides by 4. So we're going to get x squared equals 64 over 4 is 16. And then we're going to take the square root of both sides. So x is equal to plus or minus the square root of 16, which is actually plus or minus the square root of, not the square root of 4, plus or minus 4. So we get that x is equal to 4 and negative 4. Okay? It's very nice when we're able to get x squared equals some number, because we can just take the square root of that. It's very, very nice and convenient for us. We don't have to do any of the more complicated, more involved processes that we talked about. So, on to the next problem. Here we have y squared plus 25 equals 0. We have a similar situation where we don't have that middle just plain x or plain variable term. Here we have x squared plus 25. So again, or y squared plus 25, we're going to get y squared by itself. So y squared is equal to negative 25. So then we take the square root of both sides and we get that y is equal to plus or minus the square root of negative 25. However, when you take the square root of a negative number, whenever you take the square root of a negative number, we want to make sure to take I out in that case. So we have plus or minus I times the square root of 25. But the square root of 25 is 5, so we're just going to say plus or minus 5i. So in that case, we end up with y equaling 5i as well as negative 5i. And there's our solution. Okay. Again, getting something squared equals a number is going to be our most straightforward and our most direct way of trying to solve these things. So please, if you can do that, please do that. And the way we do that is we look right here to say, is there just x? Is there just some x or some number times x or something like that? If there isn't, we can do this. If there is, we need to try a different method. So let's try that different method for number 6. We do have a middle x term. So now our next goal is to say, can we factor this? Since we don't have any number here, since we don't have any a value, we can say, are there two numbers that multiply to be negative 24 that add to be positive 5? And absolutely there are. Those numbers are 8 and 3. But in case you didn't, or 8 and negative 3. If you don't see those, it's fine. Just make a list of all factors that end up being 24. So we could have end up being negative 24, excuse me. So we have negative 1 and 24. We have negative 2 and 12. Negative 3 and 8. Negative 4 and 6. Negative 6 and 4. Negative 8 and 3. Negative 12 and 2. And negative 24 and 1. Those are all of the nice numbers that divide, all the numbers that divide nicely into 24. We can take and add them together. We get, that is 23. And the number we're looking for is, we're hoping for 5. We're looking for 5 here. So then this is 10, and hey, look, there's our 5. Once you find the pair that add up to be the number you're looking for, you don't have to add any of the rest of them up. Once you find the one you're looking for, you don't need to add any of the rest of them. So here, this splits into x squared, parentheses x minus 3 times x plus 8. And the reason we factor is because when we factor, we have something times something else equals 0. One of those two things has to be 0. We're not sure which one, so we're going to say x minus 3 equals 0. We have to set them both equal to 0. X plus 8 equals 0. Solve both of these for x. X equals 3 and x equals negative 8. Okay? So we get these two as our solutions. And again, you could check them by plugging them back into the top. All right? On to number 7. Here we have a similar problem. However, we want to see if we can factor this, but we need to check and see that number is 1. So instead of two numbers that multiply to be negative 6, we need to say, all right, what is 3 times 6? Well, 3 times 6 is going to be 18, or excuse me, negative 18, because 6 is negative. So we need two numbers that multiply to be negative 18 that add to be negative 2. All right, so let's make a list. Negative 1, 18, negative 2, 9, negative 3, 6, negative 6, 3, negative 9, 2, and negative 18 and 1. So we're hoping that any of these add up to be negative 2. Negative 1 and 18 is 17. Negative 2 and 9 is 7. Negative 3 and 6 is 3. Negative 6 and 3 is negative 3. Negative 9 and 2 is negative 7. Negative 18 and 1 is negative 17. Okay. None of these numbers in this list add up to be negative 2, which is sad, which is unfortunate. But we have a bunch of different ways to deal with that. The next thing we do, we would look for it to see is this a completing the square candidate? But because that's a 3, generally it's not going to be a good completing the square candidate. So we're looking for that guy to be a 1 in order for this to be a good completing the square option. So let's use the quadratic formula. Just a quick reminder, the quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. So let's fill in some values that we know. We know b is negative 2, so negative 2 is positive 2, plus or minus the square root. Negative 2 squared is 4, minus 4 times a is 3, times c is negative 6. That whole thing is over 2 times 3. So then we have 2 plus or minus the square root of 4. 4 times 3, or excuse me, negative 4 times 3 is negative 12, times negative 6 is positive 72. 4 plus 72 over 6. So then, just to save space, I'm going to start going over to the right. So we have 2 plus or minus the square root of 76 over 6. Keep going. We want to simplify this 76 right here. So what we're going to do is we're going to make a factor tree. So we have 76 splits into 2 and 38, which splits into 2 and 19. Okay, 2 and 19. 19 is a prime number, but we do have a team of 2's that's going to escape our radical. So we're going to continue and say 2 plus or minus our 2 that escaped times our radical of the stuff that's left over, radical 19 over 6. Which we can then split into 2 fractions. 2 over 6 plus or minus 2 square root 19 over 6. This left guy reduces to 1 over 3 plus or minus this guy, this thing right here, this guy, the 2 and 6 here reduced to 1/3. So 1 and times the square root of 19 is the square root of 19 over 3. So this is going to be our x value. 1 plus or minus the square root of 19 all divided by 3 is equal to our x value. Okay? So if it doesn't factor and completing the square is not an option, quadratic formula is going to be the way to go. All right, on to the next problem. All right, here we have m's. If you don't like the whatever letter is here, change the letter to something that you do like. Don't get so hung up on the letter. It's like, it's not x. I can't do this. This is not okay. All right, treat it just like x. All right, so 5m squared plus 2m plus 2. Okay, so this, we need 2 numbers. Again, since this is not 1, we need to say, all right, what's 5 times 2? That is 10. So we need 2 numbers that add to be 10, that multiply to be, or excuse me, 2 numbers that multiply to be 10 that add to be 2. So let's see, we have 1 and 10, 2 and 5, negative 1 and 10, and negative 2, or excuse me, negative 1, negative 10, negative 2, and negative 5. Those are all of our factors of 10. So 1 plus 10 is 11, 2 plus 5 is 7, negative 1 plus negative 10 is negative 11, negative 2 plus negative 5 is negative 7. Okay, so it doesn't factor. Okay, and we have a middle term, so we can't get m squared equals some number. But, so now we want to say either completing the square or quadratic formula. Again, this guy is not 1, does not equal 1. So, don't use completing the square. No completing the square. Because it's not 1. Because a is not 1, do not use completing the square. We are going to use the quadratic formula. Negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, fill in the values that we know. We're going to say, all right, negative b is negative 2 plus or minus the square root of 2 squared is 4 minus 4 times 5 times 2 all over 2 times 5. All right, and then from here, m equals. All right, so we have negative 2 plus or minus the square root of 4 minus 4 times 5, negative 4 times 5 is negative 20, times 2 is negative 40, so 4 minus 40 over 10. All right, so then we want to make a factor tree for 40. Excuse me, not 40. 4 minus 40 is negative 36. So m equals negative 2 plus or minus the square root of negative 36 over 10. I'm going to just go up here so I don't have to keep scrolling and you can see all this stuff. So then we're going to simplify that radical. So negative 2 plus or minus, the negative becomes an I, and the square root of 36 is 6. So it's just 2 plus or minus 6i over 10. And remember, whenever we have a term with an I, it always wants to be real part. Let's see, real part plus imaginary part. Okay, we want to have some number plus some number times I. So let's split this fraction up. We have negative 2 over 10 plus or minus 6 6 over 10 times I. Actually, let's do this. 6I over 10. If you ever have something times something else divided by a third thing, you can always move one of those things off the top of the fraction and just multiply by it. Okay, so we're getting closer to that a plus bi. We actually have some number plus some number times I, but we want to make sure to reduce all of our fractions. So we have negative 1/5 plus or minus 3 over 5i. Okay, so this is our values for m. These values make our statement true. Okay, on to the next problem. So this problem looks a little scary, all right? The x and the square root of x and all that sort of stuff. So you might be tempted to use the thing that you guys, the last, that solving a square root equation, but this is actually a substitution worthy equation, right? This would be nicer to work with if it was x squared minus 5x minus 24. If we just change it to that. So what can we say x equals? Well, x would end up equaling square root of x. So x equals square root x. So then to get to x squared, we would need to say, all right, x squared. Well, if we square this side, we have to square the other side. So x squared is going to equal just, or let's actually change this variable. Let's make it u and u squared. Let's change this, make this u squared minus 5u. Okay? So these are the values that we're going to be switching out. So we make that substitution, and now we need two numbers that multiply to be negative 24 that add to be negative 5. Those numbers are going to be negative 8 and positive 3. So u minus 8 times u minus 3 equals 0, or u plus 3, excuse me. And then we're going to set both of those equal to 0. U minus 8 equals 0, u plus 3 equals 0, u equals 8, u equals negative 3. So from here, our goal is not to find the value of u. We need to find x. So since we said that u equals the square root of x, we're going to take that and plug it in wherever we see a u. Square root x equals 8. Square root x equals negative 3. Okay? So then we square both of these, and we say, all right, x equals 64. To undo the square, we square both sides, and x equals 9. But if we plug these guys in, 64, so we say 64 minus 5 times the square root of 64 minus 24 equals 0. We're checking this. So 64 minus 5 times 8 minus 24 equals 0. Well, 64 minus 40 minus 24 equals 0. All right, 64 minus 40 minus 24 equals 0. Then 0 does indeed equal 0. So that works. 64 works. But if we plug in 9 minus 5 times the square root of 9 minus 24, does that equal 0? So 9 minus, let's see, 5 times 3 is 15 minus 24. Does that equal 0? Well, as a matter of fact, it does not. All right. So 9 minus 15 minus 24 is going to give us some negative number that I don't really feel like calculating. Some negative value. Let's call it some negative a equals 0. This is not true. Therefore, 9 does not work as a solution. Okay, just 64. All right. So I think I hear people coming back. So I'm going to go ahead and end this recording here, and I will pick up and finish off in part 2. All right. See you guys there. Bye.